So now we are going to study with respect to the next problem. My next problem is what? That is your x of n. I'm sorry, really sorry guys for the interruption. So it is x of n is equal to, that is what I can say, the this one, that is minus alpha to the power of n into u of, that is minus n minus 1, right? So now we know that the very first step is, that is your x of z equation, which is the z transform of x of n. That is your summation of n is equal to, what I can say, the minus infinity to infinity. So that is your x of n into z to the power of minus n. So now what is that you have to do is, you have to take this x of n into consideration and you are going to substitute this particular. So now let me substitute this particular, right? So I'll teach you clearly this particular problem, because I've seen many of the solutions for this problem, but they are somewhat complex. So let me try to make it really simplified, right? Yes, really simplified, and there were some mistakes with respect to this particular question answer when I've seen in other sources. So I'm going to try to clear this in a particular manner, right? Yes. So now let me substitute this minus alpha to the power of n into u of minus n minus 1 into, that is z to the power of minus n, right? So now what is that you have to do? So now we have to consider u of minus n minus 1 into existence, right? If I consider u of minus n minus 1 now, why I have to consider? Because I have to, for the change of my limit here, I have to consider this particular. So if you have a unit step signal, your limit will change. So now let me consider first what I can say, my u of, that is minus n minus 1. So many people have seen they do that. So they take first the reflection and the shifting. No, it is first the shifting and reflection. So if you take reflection and shifting, you get the wrong, you get the answer, but that limit what you take, it is wrong, right? So you have to take first the shifting, then you have to take the reflection, right? So I'll write that first. So my shifting process would result in what? That is your n minus 1 is equal to 0 and your n is equal to minus 1. So therefore now I'll draw this particular this thing. So I get it as like this. So that is 1 2 3 4. So your amplitude is 1 for all 1 2 3 and 4, mere amplitude is 1, right? Yes. So now coming on to a reflection process. So what is that reflection process? So in the case of the reflection process, so you can see that, so in the case of reflection process, you can see that you are going to shift all this particular to this side. So that is what is resulting in like this. So I'll show that also. So this is what is here this is what is 1 amplitude only, but this is minus 1, minus 2, minus 3 and minus 4. So it will end, it will continue till minus infinity, right? So this is what is your signal. So what is your u of minus n minus 1? So your u of minus n minus 1 would be what? That is equal to, what I can say here, it starts from minus 1, that is minus 2, that is minus 3 and minus 4, and it continues till infinity, right? Minus infinity, and here it amplitude is 1. So this is what is your u of minus n minus 1. Many people will do mistake over here. They take the reflection first and then the, what I can say, the shifting process. No, this is what is your particular signal. U of minus n minus 1 is this one, right? This is the original answer for u of minus n minus 1, right? So now what is now we can see in u of minus n minus 1 is, so see here, your u of minus n minus 1 is starting from minus 1 time period and is continuing till minus infinity. So that is why what I can say, so now my range becomes equal to, that is my u in summation of, just a second, yes, summation of, that is what I can say here, n is equal to minus infinity to minus 1. So this is what is your summation now, right? Yes. So to eliminate u of minus n minus 1, first you have to do this particular signal process. That is what I told you, the basic operations of signal you are supposed to do with respect to u of minus n minus 1. And when you get the signal, that is u of minus n minus 1, so this is what is the resultant. That is, it is starting from minus 1 and ending till ends at minus infinity. So therefore, that is why this is what is my summation I got. That is summation of n is equal to minus infinity to minus 1. Right? So that, what is that, n is equal to minus infinity to minus 1, what I can say, minus 1, what I can say, that is equal to you are minus alpha to the power of n into z to the power of minus n. So this is what you get it now, right? So now next thing what you have to do is, so you're going to eliminate n outside, right? Eliminating n outside, what we did in the same last class, same last problem, that is you have to do the same. Now my summation is what, that is n is equal to, what I can say, minus infinity to minus 1. So here you are going to take minus outside, and this minus, what was with respect to alpha, you know, that one you are going to take it outside. So here outside, here you need to keep it. So now you get alpha to alpha into, that is what I can say, z to the power of minus 1, that is whole to the power of n you are going to get, right? So now next what you have to do is, here the summation is n is equal to minus infinity to minus 1. So now I am going to shift the limits. So I'm going to change the limit. So if I'm going to shift the limit, so what I have to do, then I'm going to shift this also. That is, this will also become my inverse. So if I want to shift my limits from n is equal to 1 to infinity, so what I have to get, I have to get the inverse of this particular. So inverse of this particular is, that is alpha to the power of minus 1 into z, that is whole to the power of, what I can say, the n, right? Whole to the power of n, right? So this is what you get. So now what is that going to happen is, many people will do a long procedure. What is that very long procedure? So I'll write this again. So see here, what did we do here? We just took what, we just shifted the limit. So that is, you got it as n is equal to 1 to infinity, that is your this is what I can say, alpha to the power of minus 1. Here minus you need to keep it without fail, and this is z to the power of n. So that z to the power of, what I can say, that is 1. This is z to the power of 1. So this is z to the power of 1 into n, right? Yes. So now here, so this minus is associated with alpha, so we removed it outside. After when we took the n as common, that is we took n as the power, so we just kept this outside, right? So now many people, what they do, they take, that is what I can say, your formula, that is n is equal to 0 to infinity, that is alpha to the power of n formula. This is looking like that only, this particular, what I can say, this is looking that like that only. So but here, as your n is equal to 1 to infinity, so that is alpha to the power of minus 1 into z, that is whole to the power of n is here, this particular, right? So as your summation is, that is summation of n is equal to 1 to infinity. So when you take this particular this summation, that is when you take this particular alpha to the power of n formula, so what you have to do is, you are going to change the summation here also. Here when you take this formula, that is a summation of n is equal to 0 to infinity alpha to the power of n, which is equal to 1 minus 1 by alpha, that is for what, that is if your summation of alpha is lesser than 1. If you take this formula, what you have to do is, you are going to change the summation here also. That is, your summation here becomes n is equal to 0 to infinity becomes. So for that, what you have to do, if you want to change a summation, so what you have to do, you are going to subtract with minus 1, and you are going to do a very long procedure. So that procedure is not at all required for you. That is another easy procedure for you. So what you have to do is, I'll also show that first. So see, if I use that particular formula, that is alpha to the power of n for summation for, that is n is equal to 0 to infinity. So what I get the resultant is, I'll get the resultant like this. So my n is equal to 0 to infinity. What I can say, that is here alpha to the power of minus 1, that is this minus you have to take, you should not forget this. So now I'll put a bracket over here, and this is z to the power of z whole to the power of n. So that is, you need to take this as minus 1, right? Minus 1. So if you take it as minus 1 here, why minus 1? Because you are changing your limits from n is equal to 1 to n is equal to 0. So you are changing the whole summation itself. My original summation was n is equal to 0 to infinity. But what happened when you took the formula of alpha to the power of n? What is that happened was that my summation in the case of alpha to the power of n formula was n is equal to 0 to infinity. So I had to change the summation to from n is equal to 1 to infinity to n is equal to 0 to infinity. So if I want to change that, I have to take it to, I have to subtract minus 1, right? Yes. I have to subtract what? Minus 1. So now what is that going to happen next is, so I have to, what I can say, I have to simplify this. So simplify in the sense I have to apply that formula, that is 1 divided by 1 minus alpha. So if I apply it, I get what? That is 1 divided by 1 minus, that is alpha to the power of 1 into z. What I can say, that is minus 1. So if I take this, so you get what? I'll write it in the next slide, the same thing, and I'll continue. So that is, if I use the formula, so I get it as minus of, that is what I can say, 1 divided by, that is 1 minus alpha to the power of minus 1 into z, that is minus 1. So if I do that particular simplification, I get like this. So that is, you get it as what I can say, that is now what you have to do is, you have to as there is a minus over here, what I have to do, I have to multiply this minus to this two things. So to this particular as well as this minus 1. So I now get what? I now get, so I'll erase this and rewrite it again. So I now get it as what? I now get it as, so that is equal to minus 1 by 1 minus alpha to the power of z. So that is minus plus 1. So now I'll do the simplification, that is, you get it as what I can say, 1 minus what I can say, so that is alpha to the power of, that is minus 1 into z inverse. So now, so that is, you get it as this minus, this 1 minus alpha to the power of minus 1 into z. So that is into 1 is this 1 minus alpha to the power of minus 1 z. So that is why you, if you multiply that one to this, you get it as 1 itself. So here for this particular, there is nothing, here it is 1. So for 1, what you have to do, if you want to get, so this particular, so you have to multiply 1 with, that is 1 minus alpha to the power of minus 1 into z. So if you multiply 1 into 1 minus alpha to the power of minus 1 into z, so you are going to get it as what? You are going to get it as this particular. So that is why now if you multiply this with 1, so you are going to get, that is 1 plus 1 minus alpha to the power of 1 into z, right? So now I'll rewrite that again. So if I further simplify, I am going to get it as what? That is, I get it as, that is 1 minus alpha to the power of minus 1 into z. So that is, you get it as 1 once again, that is plus 1 minus alpha to the power of minus 1 into z. So right, I guess I got this. So now, yes, just a second, I'll rewrite this again, guys, just a second. So now what you have to do is, you got one certain equation like this. So that is minus 1 divided by 1 minus alpha to the power of minus 1 z inverse plus 1. So right, so now we are going to get, when you do the simplification, so you are going to get it as 1 minus alpha to the power of minus 1 z. So that is equal to what I can say, so this is this into whole thing into 1 is this particular, so therefore minus 1 into 1 is minus 1, so therefore I get it as minus 1, that is what I can say, plus that is 1 minus that is alpha to the power of minus 1 into z, right? So what is that going to happen here? Minus 1 plus 1 will become equal to 0, isn't it? Yes. So now after it becomes 0, so what I get my resultant is, I get it as that is minus alpha to the power of minus 1 z, that is divided by 1 minus alpha to the power of minus 1 into z. So this is what I am going to get. So now what is that going to happen is, you saw that this was a lengthy procedure, right? If you take your formula, that is summation of n is equal to 0 to infinity, that is what I can say, your alpha to the power of n formula. So you have to do all this procedure. But what was my original summation? My original summation was, that is n is equal to 1 to infinity. So if I had to take this formula, so what I had to do, I had to change my summation from n is equal to 1 to n is equal to 0, right? So for that I need to subtract the whole with minus 1, and then once again I have to do so and so procedure. This is really a lengthy procedure. So I'll tell you really a simple procedure. So what is that simple procedure is? So first, what was the equation we got? We got the equation that is here n is equal to, that is what I can say here, 1 to infinity. So that is we got, that is alpha to the power of minus 1, that is z, all to the power of n. So where did we get? So we had the summation, that is n is equal to minus infinity to what I can say, the minus 1. So we changed this limit, so that is we brought this minus 1 to downward and this infinity to upward. So for that what we did, we just got an inverse of this also, and we got the resultant like this. So this is where we got that particular, right? So now what is that you have to do is, so now what is that you have to do after that is, I have another formula now, right? Here only we did what? Here only we used the formula, that is n is equal to summation of n is equal to 0 to infinity, what I can say, that is your alpha to the power of n formula. But you don't need to use that here. What you have to do, you can use a really simpler formula, that is a summation of n is equal to 1 to infinity. So that is alpha to the power of, that is what I can say, n, which is equal to your alpha to the power of n, which is equal to, so that is what I can say, that is your alpha divided by 1 minus alpha. That is if your what I can say, the alpha modulus is lesser than 1. This formula you need to use. If you use this formula directly, what is the resultant that you get? So the resultant that you get would be is equal to what? That is your minus alpha to the power of minus 1, that is z of what I can say, that is z divided by, that is z, that is divided by what I can say, the 1 minus alpha to the power of minus 1 z. So I guess you got it right. So you got it. So what did we do there? We did a really lengthy procedure and we got this particular result, right? We did 4 to 5 steps there and we got this result. But here with a single formula only we got the resultant. So which is easier? This one is only easier, right? So please do use the formula, that is summation of this formula. I am stressing this again. Please do use this formula, that is summation of n is equal to what I can say, 1 to infinity. So that is your alpha to the power of n, which is equal to what? That is 1 minus, so the alpha minus, that is 1 minus alpha, that is for your alpha modulus, that is lesser than 1, right? So this formula you are supposed to use. Don't use that particular formula, that is what I can say, your n is equal to 0 to infinity alpha to the power of n formula here. So I use that formula also and I showed what is the procedure, right? So this one I would be sharing it in Instagram so that you will be getting more clear. Please do subscribe to my Insta handle, that is ENC36. You get more updates on video as well as the updates on this particular video subjects also, right? Yes. So there you had to do the more and more steps. So now I got that particular step, so I'll write that step again. So see here, I got my resultant as, that is what I can say, the sorry, I'll delete this. Yes, so I got it as that is minus alpha to the power of minus n into z, that is divided by, I'm sorry guys, that is divided by what, that is 1 minus alpha to the power of minus n into z. I got it, right? So now next what I have to do is, so I can write like, I can write this one as that is equal to 1 divided by what I can say, that is 1 minus a z inverse, or I can say that is equal to what I can say, z divided by z minus a. So or you can simplify this. So if I simplify this in an easier manner, so I'll simplify this and show it to you. So here you got to know that, I'm sorry, this is alpha to the power of what I can say, the minus 1, right? I'll just showcase it to you. This is minus 1, I'm sorry, wrote it as n guys. Yes, so this is minus 1 and this is also minus 1, right? So I took it as that, and so see, I'll just do the simplification over here. So here if you simplify, so what is that you're going to get is, you're going to get it as, so that is minus what I can say, the 1 by alpha. So what is alpha inverse is 1 by alpha into z, so that is divided by 1 minus 1 by alpha into z. So if you multiply, you get minus z by alpha, that is divided by what I can say, that is what I can say, the 1 minus, so that is z by alpha, right? So if I get 1 minus z by alpha, what is the resultant? So you are going to get it as minus z by alpha, that is divided by what, that is what I can say, the alpha minus z, right? Alpha minus z divided by alpha. So I cancel alpha and alpha over here, so I get it as minus z divided by alpha minus z, or I can say that it is what I can say, the z minus alpha, I can, what I can say, so that is if you shift it, you get it as z divided by z minus alpha. So this is what is the resultant. You can do this simplification, or directly you can write it as 1 divided by 1 minus a z alpha z inverse, or I can say that it is z divided by what I can say, the z minus a, right? Yes, you can also do that without fail, right? So now what you have got, you have got your resultant z transform, that is equal to z divided by z minus a. So now there I got it that your alpha to the power of minus 1 into z, so that is what I can say, lesser than what I can say 1. So now let me simplify this. If I simplify this, that is alpha to the power of minus 1 into z, if I simplify, I get 1 by alpha, that is into z modulus, that is lesser than 1, or I can say that it is z by alpha, so that is modulus is lesser than 1, or I can say that my z modulus is lesser than, that is their alpha modulus. So this is a left sided sequence, and so for the left sided sequence, what you have to do, you have to just take what, you have to just take this particular circle that is centered at z axis. This is re of z, and this is imaginary offset, that is img offset, and then you can also see that, so here you are going to shade inside the circle, right? This is what is ROC, and a z transform, that is equal to z divided by z minus a, right? Yes, so this is what is for this particular problem, and I'll retell that particular part once again. So here I'll make two columns. So my first column would be what, I got an equation that is n is equal to what I can say, minus infinity to, no sorry, n is equal to, I'm sorry, it is n is equal to 1 to infinity, n is equal to 1 to infinity, what I can say, that is your minus, this is minus, so alpha to the power of minus n into z to the power of n, I got it, right? Z to the power of n, I got it, z, that is whole to the power of n. This is what I got it, right? So now if I use the formula, that is n is equal to summation of n is equal to 0 to infinity alpha to the power of n formula, what did I get? So I get it as, that is what I can say, the summation of n is equal to 0 to infinity, so that is what I can say, here alpha to the power of minus n into z whole to the power of n minus 1. I got it. So here I need to put a bracket over here, and this one what you have to do, the very next step what you're going to get is you are going to simplify according to the formula, and you are going to get it as that is 1 divided by 1 minus that is alpha to the power of minus n into z, that z, so that is minus z alpha to the power of minus 1. I'm sorry, this is minus 1 guys. Here I'm really sorry for the distraction over here. So this is what I can say, the minus 1. So here it is minus 1, here also it is minus 1, here also it is minus 1, right? You got it right. Here also it is minus 1. So then you are going to get it as what, like this. So this one what did you do, you just simplified. How did you just simplify? You just simplified like this. So what you did, so here there was a minus, here I left that, sorry, here it was a minus, and you multiplied what I can say, this minus to the both, and you got it as minus 1 by 1 minus alpha to the power of minus 1z, that is plus 1, and you got the resultant like this. So that is minus 1, that is 1 minus alpha to the power of minus 1z, that is you got it as 1, that is plus 1 plus, that is here 1, that is minus 1 plus 1 minus alpha to the power of minus 1 into z. So this get cancelled, which was equal to 0, and you got it as alpha to the power of minus 1 z divided by 1 minus alpha to the power of minus 1 into z. So what was that going to happen is, when you got this resultant, so you can see that this resultant you can get easily by that particular formula. That is which particular formula? In which particular formula? That is this particular formula, that is summation of n is equal to 1 to infinity, that is alpha to the power of n formula. If you use, you get alpha divided by 1 minus alpha. So what was your alpha? Your alpha was, that is alpha to the power of minus 1, that is minus alpha to the power of minus 1, that is z, divided by, that is 1 minus alpha to the power of minus 1 into z. I guess you got that right. So this is what you can get it easily. You don't need to do these steps, right? You can directly write that particular formula. What you have to do, you have to directly write that particular formula, that is summation of n is equal to 1 to infinity, that is what I can say, the alpha to the power of n, which is equal to alpha divided by 1 minus alpha. So therefore you are going to get the resultant as, that is minus alpha to the power of minus 1z, that is divided by 1 minus, so that is alpha to the power of minus 1z. So you can get it directly, no need of doing those particular steps. So that is what I want to tell, and this is what is for this particular problem, and thank you.